Welcome to Chapter 5, questions 101 to 105. Question 101. For each table below, find the missing entries and write an equation. So it's given us on Part A, the month and the population, and we got to figure out what the pattern is so that we can find the missing entries and then write the equation as well. So as we look here, 2 goes to 8 by multiplying by 4. 8 goes to 32 by multiplying by 4. So therefore we'll continue that same pattern and we'll just continue to multiply the populations by 4. 32 times 4 is 128. 128 times 4 is 512. 512 times 4 is 2,048, and 2,048 times 4 is 8,192. So therefore, we have the missing entries, and now we need to write the equation. Well, it is being multiplied by 4, so we do know that we are looking at a geometric sequence or an exponential function. And since we have y and x here, we'll go ahead and say y, which is the output, is equal to the initial population, which started at 2, times its multiplier, which was 4, its generator. So y is equal to 2 times 4, and then raised to the x power. So that would represent the equation. Your input is month, and your population is y. So if I plugged in 0 for x, it would be 1. 2 times 1 is 1. Plugged in 0 or 1 for x, it would be 4. 4 times 2 is 8. So that would represent your equation for the population and the month. On Part B, we're going year and population, so pretty similar here. What do we have on this one? On this one, we're going from 5 to 6 and 6 to 7.2. So we can work backwards, and we can take, once again, 5 times what value is equal to 6. And if we divide that, we get 1.2. So 5 times 1.2 is 6. 6 times 1.2 is 7.2. 7.2 times 1.2 is 8.64. 8.64 times 1.2 is 10.368, and we'll just start rounding these to the nearest tenth. So 10.4 times 1.2 is 12.4, and 12.4 times 1.2 is 14.9. And these are approximations at this point, starting at 4. So once again, our equation would be population is equal to the initial population, which was at 5, times the multiplier, which is 1.2, raised to the x power. So once again, y is equal to, instead of writing the multiplication, I can just do parenthesis 1.2 raised to the x power. Question 102, convert each percent increase or decrease into a multiplier. So if it's a 3% increase, then that's 100% plus the 3% increase, which as a decimal would be 1.03. For B, it's a 25% decrease, so we're subtracting 25%. So that would be 75%, which is equivalent to 0.75. On C, it's a 13% decrease, so you start at 100%, you subtract your 13%, and that would leave you with 87% as a decimal. That's 0.87. And then on D, we have 100% plus the 2.08% increase. So that would be 102.08 0.08%, which would be equivalent to 1.0208 as a decimal or as a multiplier. So we're looking to see what that multiplier is when we're talking about those percentage increase or percent decrease. 103. So Mr. C is such a mean teacher. The next time Matthias gets in trouble, Mr. C has designed a special detention for him. Matthias will have to go out into the hall and stand exactly 100 meters away from the exit door and pause for a minute. Then he is allowed to walk exactly halfway to the door and pause for another minute. Then he can again walk exactly halfway the remaining distance to the door and pause again, and so on. Mr. C says that when Matthias reaches the door, he can leave, unless he breaks the rules and goes more than halfway, even by a tiny amount. When can Matthias leave? Prove your answer using multiple representations. So if we're looking at this, one way we can look at this is by a diagram. And if here is the door, and here is where Matthias stands, which is 100 meters away. And then for every minute, he gets to go halfway. So in 1 minute, he is at 50 meters. And then he goes and waits, and then another minute, so we'll say 2 minutes, he is at 25 meters. And then he goes halfway again, which is 12.5 meters. And then halfway again, which would be 6.25 meters. And then halfway again, and halfway again, and halfway again. And so what's going to happen is, theoretically, Matthias will never make it to the door because he continues to go halfway, and therefore will never be able to make it there. Eventually, those numbers are going to get so small it'll be very difficult for Matthias to even walk that distance, but ideally or theoretically, that's what would happen. He would never make it there. Another way to look at this is using an equation where y is going to represent that distance, and he's initially 100 meters away, and his multiplier is 0.5 raised to the x power, so where x represents the number of minutes that have passed. And so therefore you can make x as large as you want, but y, no matter how large x is, will never be 0. It'll get very, very close, but it'll never be 0. And so when can Matthias leave? Technically, Matthias can never leave based on kind of the two representations that I used here. And so I just say that Matthias can never leave because he will never reach the door without breaking the rules. Question 104, simplify each expression. So we are looking at some of the properties of exponents that we have learned. So multiplication, 2 times 4 is 8. M to the third times m to the second is m to the fifth power. You add your exponents. With division, you can simplify. So that would be negative 2 thirds. And then you can subtract your exponents with division, which would be 2 minus 7 would be negative 5. And then we have to move the y to the negative fifth to the denominator and make it positive y to the fifth. So negative 2 divided by 3y to the fifth power. And that was actually question C, went out of order. On question B, 6y to the fifth divided by 3y squared. So divide the 6 and the 3. And that would be 2. And then subtract your exponents. 5 minus 2 would be 3. So 2y to the third power. And then on D, this is being raised to the third. On this one, I'll show you expanding it out. Remember, you can always expand these exponents as well, or these expressions, and then do the property. So negative 2 times negative 2 times negative 2 would be a negative 8, and then x times x times x times x times x times x would be a total of 6. So negative 8x to the 6th power. For this problem, refer to the sequences graphed below. So you have 3 different sequences. Identify each sequence as arithmetic, geometric, or neither. And then part B, if it is arithmetic or geometric, describe the sequence generator. So I'm just going to call this 1, 2, and 3. So we'll say 1A. This one right here looks to be arithmetic. It looks like we can draw a line through those. Maybe not my best line, but so we believe this is arithmetic for 1A. For 1B, looks like neither because it does go down and then comes back up. That looks more like a quadratic. So following the directions, we'll say neither. 1C, this one looks to be more geometric. And then the next part on B, if it is arithmetic or geometric, which would not be 1B, describe the sequence generator. So on number 1, it looks like if we go down 3 to the right 1, down 3 to the right 1, same thing over and over. So it looks to be -3, is that we will be adding -3 each time. And this is actually 1B is the question we're answering, adding -3. 16 is neither, so we don't have to worry about that. And 1C, what is it that we are multiplying by? So if you find a point, right here is at 1, next one's at 2, 4, 8, 16. So it looks like it's getting multiplied by 2 when I wrote it that way, but remember, we're actually starting at 0 and going to 1. So it's 16 to 8 to 4 to 2 to 1. So you're actually multiplying by 1/2. So multiplying by 1/2, and you do want to make sure that you say multiplying by 1/2. So those are the generators for 1A and 1C. I just realized I mislabeled this top one, so this is 1A. Alright, and that is it for questions 100 to 105.